Alright, welcome to this video. In this video, I'm going to talk about how do I apply exponential functions in the real life problem. So one of the applications that we cover in this class is finding the compound interest. Okay, so what is the difference between a simple interest and compound interest? So in the simple interest, suppose you invest 1,000 or you deposit $1,000 in a bank. The simple interest means, so suppose the interest rate is 5% per year. So 5% of $1,000 is $50. So every year you get $50 interest. Okay, so that interest will not be added to your principal amount, and it will never become 1,100, 1,200, and then you calculate interest from that bigger amount. So in the simple interest, every year the bank calculate interest for the principal amount you invested at the beginning. But in the compound interest, what they do is they add the interest to the original principal amount. For example, at the first year you invested $1,000. Suppose on the first year you earned interest $50. That $50 will be added to your principal amount, and for the next year the interest will be calculated from $1,050 because they add the principal amount and then the interest you earn in the first year, and then they consider that as the principal amount, the total amount as the principal amount, and then for the next year they calculate interest from $1,050, and similarly they keep doing that. Okay, so that is the difference. All right, so this formula is for the compound interest, compounding n times a year. Okay, the formula is A is the total amount you get, P is the principal amount you invested at the beginning, 1 plus R is the interest rate, N is the number of times you calculate interest per year, how many times in a year you calculate the interest, and T is the time in year. Okay, so R is the rate and N is the number of times the interest accumulated or calculated, and T is the time in years. So let us see an example, then the things will be clear. Okay, let us see example number 1. Find the total amount if $1,000 is invested. So what is P? P is 1,000. That is the initial investment at the rate of 4% interest rate. So what is the R? R is 4%. So how do I write this in the decimal? It is 0.04, right? Because to get rid of the decimal, you divide by 100. That will make it 0.04. It's compounded quarterly, means what is N? How many times a year they compound? Quarterly means 4 times a year. N is 4. And then how long do you deposit? Do you invest that amount? It's 2 years. So T is 2. Now use that formula. So you want to find out A, right? Find the total amount. That's why A equals to P times 1 plus R over N to the N times T, right? Let's plug in all those values. What you get is 1,000 times 1 plus 0.04 divided by N is 4 to the N times T. N is 4 times T is 2. If you use calculator for this, you will get 1,082.86. That's what you get. Okay, this is the total amount you get after 2 years with these conditions. Let us do one more example of this type. How much money should be invested? What is the principal amount? That's what it is asking. What is the P? In order to get $500, you want to get A equals to 500. By the way, you can write A equals to what? A equals to question mark there, right? This is what it is asked. Here P is asked, A is given. Okay, T, the time is 3 years. They are investing 3 years, and the rate is 6%, right? That is same as 0.06. Now use that, you plug that into the formula. What do you get? You have the formula is A equals to P times 1 plus R over N to the N times T, right? What is A? Is 500 equals to P times, let's plug in the value, 1 plus R is 0.06. By the way, what is N in this problem? Compounded monthly means N is 12 times a year they compound, right? How many times a year? How many times you can write a year? the interest is compounded. Here, since it is compounded monthly, it will be 12 times a year, right? Over 12 times to the 12, n is 12 times the t is 3. Okay, so if you use calculator, there is p, this quantity you will get in the calculator, you will get times 1.19668. okay, this is what you get. Now divide by that quantity on both sides. What do you get? 1.19668, 1.19668. so you cancel that. Therefore the principal amount that you should invest, use calculator, get 417 times 82. That's what you get. Okay, so this is the case if the interest is compounding n times a year. If you compound daily or monthly or quarterly or half yearly, like that. Okay, but if the interest is compounded continuously, continuous compounding, this will be the formula. Meaning when n is too big, when n tends to infinity, then this part will become e to the rt. That part will become e to the rt. So the formula is a equals to p times e to the rt. That is the formula, where a is the total amount, e is the irrational number, e that has, in your calculator you can see that e, and then r is the interest rate and t is the time. Let us do this example. Find the total amount if $150 is invested. What is p? P is 150, right? At a rate of 5%. So r is 5%. So that will give you 0.05. Compounded continuously. So it is compounded continuously means we will be using this formula, right? And over 4 years. So t is 4. So what is asked is a equals to what? We just use the formula a equals to p e to the rt. Okay, so just plug in p is 150, right? E to the r is 0.05 times 4 times 4. If you use calculator, you will get 183.21. That's what you will get if you use calculator for this. You use 150 times e to the 0.05 times 4. That is in the exponent. The whole thing is in the exponent. You'll get 183.21. So this is under the continuous compounding. Okay, the interest is calculated every day, like every second. You could think that way. Okay, let us see the last example. It says, how long does it take? That means t equals to what? It is asking t, right? T equals to what? For $10,000, that means p equals to 10,000, right? To become 25,000, that means a, the total amount will be $25,000 with 8% interest rate. R equals to 8%, 0.08. These are the given things. And the first problem is compounded quarterly. If you compound quarterly, then we will be using this formula, right? So it will be n equals to 4. You see that? So now we use the formula. What is the formula? A equals to P1 plus R over n to the n times t. So what are those values? It is 10,000. Let me write here basically. So 25,000 equals to 10,000, right? 1 plus R is 0.08, right? Divide by n is 4 to the n is 4 times t. You see that? Now we need to solve that one, okay? So what you get is, you get, let's divide by 10,000 first, because there is a product you can divide by 10,000. If you divide by 10,000 here, 10,000, and then divide by 10,000 here too. Okay, so what do you get if you divide by 10,000? You'll get 2.5, and that will cancel out, equals to, if you use calculator, you will get 1.02 to the 4t. How do I solve this for t? You need to take log on both sides. You can take ln on both sides. If you take ln on the left side and the right side, what do you get? ln 2.5 equals to, but the properties of the log, if you take ln on the right side, that exponent will come to the front, in front of the ln. So 4t times ln 1.02. Now what you do here is, you want to solve for t, right? You need to divide by 4 on both sides and ln 1.02. So divide both sides by ln 1.02. So ln 1.02, and then you can divide by 4 ln 1.02 and then 4 ln 1.02, right? You cancel out, you cancel the 4, so you will get on the left side, if you use calculator, you will get, so t equals to 11.57. That's what you will get if you use calculator. ln 2.5 divided by 4 times ln 1.02. If you do that, you will get 11.57. Okay, but if you compound the same problem, but you are compounding continuously, okay, you are compounding every second or so, or every day or so, in that case it should be taking shorter time to become that amount, right? Because you are compounding only 4 times a year, but here you are compounding continuously, like every day or every second, right? So in that case, just use the formula. You get, what is the formula there? What is the formula? A equals to P e to the RT, right? Let's plug in those values. 25,000 equals to 10,000 e to the 0.08 times t, right? Again, as previous problem, as this problem, divide by 10,000 on both sides. Divide by 10,000 on both sides. That's what you get, 2.5. So you get 2.5 equals to e to the 0.04 t. So we want to take ln, or natural log, or the logarithm on both sides. If you take ln on both sides, you will get ln 2.5 equals to 0.04 t ln e. But what is ln e? That is 1, right? So you need to divide by 0.04 on both sides. 0.08, not 04, 0.08. So 0.08, okay, 0.08. So divide by 0.08, divide by 0.08. What do you get? You get t equals, because ln e is 1, so t equals to, you divide ln 2.5 over 0.08, you will get 11.45 here. See, what did you get here? You got 11.57, and here you got 11.45. So basically, in shorter time, you can make this amount. Starting from 10,000, you can make 25,000 with the interest rate 8%. If it compounded quarterly, it takes a little bit longer than compounded continuously. Okay, so these are the application of the exponential function. I will give you one more and final example on the application. So in number 1 and number 2, we applied the exponential function into the compound interest, compounded n times a year and compounded continuously. So another application of the exponential function is the population growth. Okay, so if there are n0 population at the beginning, and if the population grow with the rate k, then the population at any time t is denoted by nt, and it is given by n0 times e to the k times t, n0 times e to the kt. Okay, this is the population growth model, or exponential growth model. We call exponential growth model. Okay, where if k is positive, then the population will grow. If k is negative, the population will decay. Where nt is population at time t, n0 is the initial population, k is the growth rate, and the t is the time. Let us see an example. Okay, then we will see how can we apply this model. There were 100 grams of bacteria at the beginning. So this is the beginning bacteria. So there were 100 grams of bacteria. If they grow with the rate of 0.0045, this is the growth rate, right? Then find n0 comma k, and then write this equation. That's what it says, equation for the population growth. So what is n0? n0 is 100, right? What is k? K is 0.0045. So what is the equation for the population growth? Is, you can write nt equals to, n0 is 100 times e to the k is 0.0045, and then times t. This is the equation for the population growth. Okay, let us look at the second example here. So what is the population after 5 days? That's what the question says, right? So after 5 days means we will use the same model. What we have is nt equals to 100 e to the 0.0045 t, right? So you want to find out the population after 5 days means n5. So how much would that be? 100 e to the 0.0045 times 5, right? And then you find out that using the calculator. So if you use calculator, you will get 102.2755, that many grams, okay? Now, how long does it take to reach 140 grams? What is given there is NT. We will use the same model for all the problems, right? So NT is 140. We have NT equals to 100 e to the 0.0045 t. Now it is 140 equals to 100 times e to the 0.0045 t. Now divide both sides by 100. What do you get? If you divide both sides by 100, let me divide that by 100 and divide this side by 100 too. So what you get is, you get, that will cancel out, right? So you will get 1.4 equals to e to the 0.0045 t. You see that? Now what do you do is you need to solve for t. So we need to take ln on both sides. What you get is basically ln 1.4 equals to, when you take the log on the right side, that exponent will come in front of the log, right? So it will be 0.0045 t times ln e. What is ln e? Ln e is 1, right? So you will get ln 1.4 equals to 0.0045 t. Now divide by 0.0045. You will get, let me divide that, 0.0045 and then 0.0045. Okay, so what do you get? Just use calculator because that will cancel out. Okay, you will get ln 1.4. So it is ln 1.4, right, divided by 0.0045 implies 74.77. This will imply 74.77. Okay, so 74.77 equals to t. That's what you get. Okay, so t is 74.77 days. So it will take 74.77 days to reach the bacterial population to be 140 grams. All right, so the last one is find the doubling time. What do you mean by doubling time? Is when the population become double of the initial population. At the beginning, that it was 100. Now we want to find out when will reach 200. When will it become 200? Okay, again use the same equation there. Use the same equation, meaning we have n of t equals to 100 times e to the 0.0045 t, right? Now 200, because doubling time means when will it become 200, right? So 200 equals to 100 e to the 0.0045 t. Now again exactly follow the same idea. Okay, divide by 100, divide by 100. So 2 equals to, you cancel out that, right? You will get e to the 0.0045 t. Now take the natural log on both sides. What do you get? If you take natural log, you will get ln2 is equals to, so if you take natural log on the right side, you will get that exponent come before the natural log. So 0.0045 t and then natural log of e, right? That's what you get. Now, but the natural log of e is 1, right? This value is 1 basically. Now how do you solve? Is you divide both sides by 0.0045. Let's do that. Let's divide both sides by 0.0045. 0.0045 and then 0.0045. That will cancel out. So if you use calculator, you will get t equals, so this will implies t equals natural log of 2 divided by natural log of 0.0015, right? So 2 divided by natural log of 2 divided by natural log of 0.0045. So it will give you basically 154.03, 154.03. So it takes 154 days to become the double, those bacteria double. Sometimes it says the half-life, if k is less than 0, okay, if k is less than 0, your formula will have negative sign in the exponent, because when k is less than 0, that k will be negative, right? That formula will be negative there. In that case, you can find out the half-life, meaning when will the bacteria will become half or so. Because if there is a bacteria and then if you give some treatment or the medication or the antibiotic, then the bacterial population starts to go down, and then you can find out when will that be half of the bacterial population and so on. Okay guys?